All right, guys. This is semester 2, week 11 FRQ notes. In this video, we'll be going over a couple FRQs. Our first one is 2014 question 2, letter C. It says, let R be the region enclosed by the graph of f of x here, and the horizontal line y equals 4 is shown in the figure above. So we can see here that this is obviously the y equals 4 because it's a flat line. And this curve here is the f function. And another thing to take note of is this is a calculator-based question. You can tell that because look at the weird equation they gave us, first of all. A lot of times the calculator-based questions have weird equations, but also it's a question 2. The first and second questions are always calculator based. All right, so part C says the vertical line x equals k divides R into 2 regions with equal areas. So we want to imagine an imaginary line that would cut R into 2 equal areas, and it has to be a vertical line. So that would be a line that maybe, I don't know, I might guess it to be like right about here. So we'll call that K. That way the area to the left is approximately equal to the area to the right. It says write but do not solve an equation involving integral expressions whose solution would give the value of K. So basically we're going to have an integral on this side and an integral on this side. The integral on the left represents the area on the left. The integral on the right represents the area on the right. And for this one, you could tell it goes from 0 up to k. And then for this other area over here, it starts at k, and it ends right here where they're crossing, which I don't know right now, but we can figure that out on our calculator, so we'll do that in just a second. And then finally, you also want to be aware of how to set up your integral. Remember, it's top minus bottom. So in each of these areas, the yellow one is on top of the green one here. So it's going to be 4, that's the yellow one, minus f, which is the green one. And since these two areas are equal to each other, what we'll do is we'll just put an equal sign in between them. And that's an equation, because we have an equal sign. That's an equation that involves integral expressions. So really all I need to do now is I need to find out what that question mark right there is. And for that, we'll be using the graphing calculator to find where they intersect. So I've typed the functions in here, and then we're going to graph it. And I want to find this point where the y equals 4 crosses the f function. So we're going to go to second, calc 5 for intersect, and we're going to scroll over to where they intersect approximately, and then we're going to push enter 3 times, and it tells me they're intersecting at 2.3, it looks like. And so the last thing I need to do is I just need to go ahead and replace that question mark there with 2.3. So this is an equation of 2 integral expressions that if you were to solve it would help us find out what the k value is. And that's as good as we're going to get with that. And so here is the final answer. And let's take a look at how they're grading this thing here. You get 1 point for the area of one region. So if you basically knew that it was 4 minus f of x, I think that's good enough. That would be what they're talking about there, just how to find the area top minus bottom, and then having the equation present there. This is a really strange way of grading it, honestly. I'm not too sure, but needless to say, it's 2 points. I would say what matters in this question, though, regardless of what they're saying over here, is finding that intersection point matters, knowing top minus bottom matters, and also these limits matter. 0 to k and k to 2.3. So that's 3 things that I would really want you to look out for as you're accomplishing this. I could see why they made it 2 points. That's a really strange way of breaking it up to me, honestly. But anyway, let's go ahead and take a look at our next one. Okay, so this is 2012, question 2, which means it's another calculator-based question. It says, let R be the region in the first quadrant bounded by the x-axis. Let me highlight that. It's always good when you're doing these area questions to be aware of each piece that they're referring to. The x-axis, the graph of y equals ln of x. So that's probably the curving one here. And then finally, y equals 5 minus x. That would be this guy here, as shown in the figure. Let's read the question. Now, just so you guys know, this question is the same question that we just did, but it does have a little twist. And you'll see what it is in just a second. So it says the horizontal line, there's your twist, the horizontal line y equals k divides R into two regions of equal area. Write but do not solve an equation involving one or more integrals whose solution would give you the value of k. So it's the same question, but this time they're talking about a horizontal line. So we're talking about a line like maybe like right about here that would cut the area below and the area above into two equal areas. So this means that we're going to be integrating in an upward fashion, which means that we're going to be integrating with respect to y this time. So we're going to have two integral expressions, and we're integrating with respect to y this time because we're integrating in an upward direction as opposed to a left and right direction. So once again, starting from the y value, we start at 0, and then we're going to get up to this line here, which we're calling k. And then the next one picks up at k and moves up to this point here, this y value where they cross. And once again, we're going to have to find where they're crossing. Now, since we're doing this, though, with respect to y, we're going to need to change these equations here. These equations are written with respect to x. So I need to change them. For this one, we're going to raise both sides to the e power. And that cancels that out, and we have this. So now, instead of using ln of x for that orange function, we're going to use this instead. So I'll cross that off. We also need to change this one over here, y equals 5 minus x. For this one, I would add the x over first to the other side, and then I would subtract the y. And so I'll be using that there instead of the other one. They're the same, these equations would give you the same graph, it's just that they're written in terms of y instead of terms of x. So there's that. Another thing you need to keep in mind when you do these integrals is that it's not top minus bottom, but right minus left. Now, as you guys can see, the pink one is to the right of the orange one. So it's going to be this function minus this function. I'm going to go ahead and rewrite my integral, though, a little bit. I'm going to need more space to fit that in there. So there's that. So the last thing that remains is I just need to find where they're intersecting. And it's important to also remember that since we're doing this with respect to y, I don't want the x value. I want the y value of the point of intersection. Now, whenever I use my graphing calculator, I'm not going to graph these functions, okay? I'm going to graph the original ones up here, and I'm just going to look at the y value. So let's go ahead and go to our graphing calculator. So like I said, I'm just graphing the original functions here. And I want to find this place right here where they're intersecting. So second, Calc 5 for intersection. I'm just going to scroll until I get my cursor where they're crossing. And I'm just going to push enter 3 times. And there's my answer. But remember, I want the y value of where they're crossing. So I'm going to put 1.307 as my answer. So we'll erase my question mark there. And we'll put the answer in there, 1.307. So this question was really the same thing as the last one. It's just that the difference is we had to change our functions to be in terms of y, And we also need to make sure that our final value here was a y value. Why are we doing that? Because we're cutting our areas up horizontally, which caused us to have to do a different kind of integration. And once again, I think we can go down here and just look at the answer. They're probably going to grade it in a similar way. Now, see, I like the way that they're grading this one better. They made it worth more points. And now that I'm looking, this is kind of an interesting, this is a different answer. I'll explain why they got a different, we would still get credit for our answer, just so you know. This is a different way of answering the question. But it does say you get 1 point for the integrand. So you'd have 1 point for having this correctly set up. The integrand is the part inside the integral. You'd get 1 point for the limits. So we had from 0 to k, and then from k to 1, I think it was 1.3 or something like that. And then finally just writing it as an equation. But you'll notice their answer is different, and here's why. They only focused on the lower half, and they set that equal to the half of the actual area. So and the reason they did it this way instead was because they already calculated the area in question 1. They already figured out that the area was 2.986. So instead of saying this integral equals the other integral, they said this lower half integral is equal to half of the total area, which is another way of doing it. It's just that since we're only doing part C, I went ahead and solved it the same way we did the other one. Notice that and the reason why I know that our answer is okay is because look at the directions here. It says, write but not solve an equation involving 1 or more integrals. So they did it with 1 integral, but I did it with 2 integrals. They're both valid answers, but just wanted to do that. And I think we'll stick with the way I did it, just because they connect with the last one that we did. So let's go ahead and move on to our next question now. All right, so for 2009 question 4, this one's a no calculator question. Okay, so no calculator allowed for this one. Once again, questions 1 and 2 are calculator questions. The questions 3 through 6 generally are not. But let's go ahead and continue here. So it says, let R be the region in the first quadrant enclosed by the graphs of y equals 2x. So let's highlight that one first. I believe y equals 2x. That's a linear function. So that has to be the straight line there. And y equals x squared is a parabola. So that would be this curving one here. As shown in the figure at the right there. So the region R is the base of a solid. Okay, so now when they say this, we're talking about the cross-section problems. For this solid, at each x, the cross-section perpendicular to the x-axis, that means we're going to be integrating with respect to x, has an area of this. Now this is a little different than our regular cross-section problems, but we did do one like this in class. Find the volume of the solid. So here's the steps that we talked about in class about how to do these cross-section problems. We want to know, first of all, is it perpendicular to the x-axis or not? We've already done that, so we know we're doing dx there. Step 2, 3, 4, and 5 are actually all useless to us. Now, I'll explain why that is. The reason is because the whole purpose of 2 through 5 is to get the area of your cross-section, which is the base squared, which gives you the area, and that's what you integrate. But the thing is, on this problem, they tell you what the area is of the cross-section already. So all we need to do is we just need to do an integral from the first intersection point to the last intersection point and put the area formula that they gave us in here. So that's it. It's actually a lot easier than the ones that we did. It's just weird. So we don't have to find the area of the cross sections. They give us the area of the cross sections. So we don't have to worry about doing function 1 minus function 2 and squaring it and putting the right formula in there. I'm going to back up a little bit. You do need to make sure that your equations are in the right format if you're going to use them, but we're not going to. And you do need to use the intersection points. On this problem, though, I'm pretty sure they gave us both intersection points, so it doesn't matter. But the point is that steps 4 and 5 is how you find the area of the cross-section, but we don't need to because they gave us the area of the cross-section. So we're integrating with respect to x, and we're going from x equals 0 to x equals 2, and they give us the area of the cross-section, and that's it. So now the rest of the problem is going to be us doing some integration here, but that's all old stuff. So this is important here, making sure you guys understood how I got this set up. When you want to find the volume of a solid with known cross sections, you just need the area of the cross sections here. And usually we find that area by doing function 1 minus function 2 and applying that to the proper formula. But in this case, they just tell us the area. So we're going to use the area that they give us. So let's go ahead and integrate this thing. Okay, so first of all, notice that we have an inside function, which means that we're going to be doing some u substitution. My u is pi over 2x, which means that du over dx is going to be pi over 2. And then as we get the dx by itself, the first thing I would do is put the dx on the other side. And then I'd move the 2 to the other side. And then finally I would divide by pi. And I end up with that if I want to get dx by itself. We're also going to need to change the limits when we do our u substitution. So here we go. We have sine of u and 2 over pi du. To change the limits, you just plug the x values in. So if I plug in 0, I still get 0. If I plug in 2, pi over 2 times 2 would just be pi. Now I'm going to take this constant and move it out to the front. And now we have a simple trig integration. The integral of sine is negative cosine. We'll go ahead and plug these values in and see what we get now. Negative cosine of pi minus negative cosine of 0. And since this is an FRQ and the rest of this is pre-calculus material, we don't need to simplify that. We can leave it just like that. Now, we'll see the answer. They will put the simplified answer on the answer key, but just know you can stop here. You don't have to worry about simplifying the trig on an FRQ, and that would be our final answer there. So let's see how they graded it. So you get 1 point for having the proper integrand in place. So if you just knew that you're supposed to put the area there, that's worth 1 point. The next point is having done your integral correctly. Did you end up getting the 2 over pi negative cosine? That would be another point. And then your final answer, which once again, we had the final answer, we didn't simplify it, and you don't have to simplify it. So there it is. Now notice that whereas we did the u substitution and I just left this as a u and I changed these numbers, they decided to put the u back and go back to the original x values, which you can do, but just take my word for it. What we did is good also. So there you guys have it. That's a 3-point question. That kind of impresses me because that's really not that challenging of a question. But anyway, there it is. Now, just so you guys know, on your practice for this week, you don't have to do the integration by hand. I'm just letting you use a calculator for all of the questions. So don't feel like you need to do the integral by hand. I mean, if you can, go for it. I can't remember if I made the functions of a nature where you could do it by hand or not. I'm not sure. So, but feel free to use your calculator if you want to for that one on the practice. Anyway, hopefully that was helpful. We'll see you guys later.